Welcome to our video lesson for section 1.5, part 1, function operations. We're going to look at how we can algebraically combine functions using operations like addition, subtraction, multiplication, and division. To begin with, we have the sum of two functions, which you notice is f of x plus g of x. So we're literally adding two functions together. An alternate notation that we can see for this would be f plus g of x, and that is also telling us that we are again adding the two functions together with respect to the variable x. Looking at the difference, again, subtracting the two functions, f of x minus g of x could be rewritten as f minus g of x. And then we have multiplication. Here we see that we are multiplying the two functions together. One thing to note is that we can see this dot, and that's going to be similar to something that we use for the composition, but slightly different. So we got to pay attention between multiplication and composition, which I'll stress a little bit later. But again, we see we're multiplying, and we also could rewrite that as f times g of x. And then last but not least, division. We can see f of x divided by g of x, which could be rewritten as f over g of x. So the key thing to focus on here is that we have two different ways to write each notation, but they mean the same thing. For our first example here, you see that we have g minus f of x, so we're going to go ahead and subtract f from g. I'm going to start by writing down function g, which is x squared plus 3x. And then I'm going to subtract, and I'm going to be careful here because I'm subtracting the quantity f of x. I'm going to put in parentheses. And we're going to need to make sure that we distribute that negative sign. That way we don't miss out any changing of signs for our terms. So what we get now is going to be x squared plus 3x minus 4x minus 8. And then we're going to clean this up by combining like terms. And we end up getting x squared minus x minus 8. Looking at our function and thinking of domain, we want to look for things like fractions or square roots, where there's certain numbers that we can't plug in. And since this function doesn't have either of those two features, we're allowed to plug in any x value that we want in the real number system, which means our domain is going to be all real numbers. For our second example, we see that we have f times g. I'm going to go ahead and write down my two functions. I have f of x, which is 4x plus 8. And we're multiplying that by g of x, which is x squared plus 3x. Again, we're going to have to use this idea of distribution to make sure we multiply everything together correctly. And we end up getting 4x cubed plus 12x squared plus 8x squared, and then plus 24x. All right, just like we did before, we're going to go ahead and clean things up, and I want to make sure that I'm writing things in descending order, which they fortunately already are. We have 4x cubed plus 20x squared plus 24x. And just like with our last question, we want to talk about domain. We look at our function. There's no fractions. There's no square roots. So our domain is going to be all real numbers. All right, for our next example, we have k over f of x. So we're going to go ahead and start with our k function, which is negative 5x plus 10. Put that over our f function, which is 4x plus 8. And then we're looking to try and simplify. In order to simplify, we want to be able to factor. If I look at my numerator, I can factor out a negative 5. And I would have an x minus 2. In my denominator, I can factor out a 4. I would have an x plus 2. And then we notice that nothing is going to simplify. And since nothing is going to simplify, that means that this original expression is actually our best answer. But by factoring it, we can take a look at values that we can exclude from our denominator. If we look at this factor of x plus 2, and I take that specifically and I set it equal to 0, then I get that x is equal to negative 2, which means if I plug a negative 2 into my function, I'm getting to 0 in my denominator, and I don't want that. So my domain then is going to be everything except x cannot equal negative 2. If you look at our next example here, again a division problem, we have f of x over h of x, which is going to be 4x plus 8 over negative 2x squared plus 6. Again, our goal here is to simplify, so I'm going to factor out. I can take out a 4 from my numerator, and then I can take out a negative 2 from my denominator. And then I can do a little bit of simplifying here. I can divide that 4 by negative 2, and what I'm going to end up getting would be negative 2 times x plus 2 over x squared minus 3. And there's nothing else to simplify here, so I have my simplified expression. But I do want to look at the domain. Again, we're going to look at our denominator, and I want to set that equal to 0. And if I set that equal to 0 and I solve, then we end up getting that x is equal to the, plus or minus the square root of 3. And those are the values that would give me a 0 in my denominator. And again, with fractions, we can't have 0 in our denominator, which means our range is going to be everything except that plus or minus root 3. Okay, you have 2 questions to try on your own now. Go ahead and hit pause, try those 2 questions, and then check back in and see how you did. All right, so here I have my 2 answers. For your option C, we have negative x squared plus 3x plus 6. Again, no fractions or square roots, so no restrictions on our domain value. And then for your option B, we have negative 20x squared plus 80. All right, what we're going to do now is essentially the same thing, but instead of evaluating the function for x, we're going to evaluate the functions for a specific value. All right, so if you look at our example here, we have f minus g of 4. And we're going to do this a couple different ways, but the first option we're going to plug in 4 first. So what that means is we're going to evaluate f of 4. We're also going to evaluate g of 4, and then we're going to subtract what we get. So for f of 4, if we plug in a 4 for that x, then instead of 4x, we have 4 times 4 plus 8, and we end up getting 24. And then for g of 4, instead of that x squared, we have a 4 squared plus 3 times 4 instead of 3 times x, and that's going to end up being 28. And then because we're subtracting, again, we're going to do f of 4 minus g of 4, which is 24 minus 28, and that gets us a negative 4 for our final answer. The other way to do this, option 2, is to go ahead and plug in 4 last. So we're going to do f minus g of x, and then we're going to plug in a 4. So we're going to write our f function first, and then make sure we put our g function in parentheses in case we need to modify it based on distributing. We're going to make both of those terms the opposite here. So now we have 4x plus 8 minus x squared minus 3x. And if we clean that up and get it in descending order, we get negative x squared plus x plus 8. And now we're going to go ahead and plug in a 4. So then we have negative 4 squared plus 4 plus 8. And if we pay attention to our order of operations, we get the same answer. And so what we see here is 2 different ways to get the same answer. You can plug it in first and subtract, or you can find the difference of the 2 functions and then plug in your value. All right, your turn. I want you guys to go ahead and attempt the h over f of negative 3. Again, do it either using option 1 or option 2. You can plug in the negative 3 first, or you can find out what h over f is and plug it in, and then figure out what your value is. But go ahead and hit pause now, try that, and then check back in. All right, plugging it in, I got h of negative 3 over f of negative 3, which simplified to be negative 6 is my final answer. All right. For our next example, we see we have f times k of 3t. So again, very similar process. We're going to do f times k first, and then we're going to go ahead and replace our variable with a 3t. So this is what we're going to be evaluating with. So let's go ahead and do f times k first. Okay, so we have 4x plus 8 times negative 5x plus 18. We're going to go ahead and multiply that together. Right, so we're going to go ahead and combine like terms. And then we want to finish evaluating, and we are doing this for an expression of 3t. So what I'm going to do is take that 3t, and I'm going to replace it everywhere that I see an x. All right, we need to simplify a little bit here, that 3t squared. I'm also multiplying that 32 by 3 there. And then the last thing I have to do here is multiply negative 20 by 9, and we get negative 180t squared plus 96t plus 144, and that is our final expression. We're going to do the same thing here with example number 9. I'm going to add my functions together, and then after I've done that, I'm going to replace my variable with what I'm evaluating for, which in this case is going to be a negative t. All right, so we're going to write down k, which is negative 5x plus 10. And then we're going to write down m, which in this case is just 12. Combining terms here, we have negative 5x plus 22. And now we're going to substitute in our expression. We're going to take in this negative t. We're going to plug it in for that x. And then when we simplify, we get a positive 5t plus 22 as our final answer. Okay, your turn to try one. We have k minus f of 6t. Again, you can do k minus f first and then plug in 6t, or you can plug in 6t to k and plug in 6t to f and then subtract, up to you. But go ahead and hit pause now and then try out the problem. All right, so you can see from my final answer here, I got a negative 54t plus 2. Hopefully you guys got the same thing. All right, transitioning here, we're going to try and do the same thing we did with function notation, but we're going to use graphs instead. So similar to the other day, we're given some domain values. We're going to look up the corresponding range values. We're going to write them down and do some algebraicness with them. Our first question here is f of 2. So we're reviewing from yesterday. F of 2 means for function f, which is the one that's on the right, we're going to go over to an x value of 2. We're going to go up, and then we can identify that the corresponding y value is going to be that 5. So in this case, our answer is just 5. For f plus g of 2, now we need to look up f of 2 and g of 2, and we're going to add them together. So we are doing f of 2 plus g of 2. We already know that f of 2 is 5, so we're going to go ahead now and find g of 2. That's the function that's on the left. We go over to 2. We see that at that value we have 0. So then we're adding 0 to 5, which means that our final answer is going to be just 5. And we're going to repeat this process for other examples as well. For f over g of 3, that would be the same as f of 3 over g of 3. So again, we're going to look up our domain values to find the corresponding range values. For f of 3, we go over to 3, we go up, and we can see that we have a value of 6. And then for g of 3, we're going to go to 3, go down, and we can see that we have a value of negative 1, which gets us a negative 6 as our final answer. For d, we are multiplying. We have g times f of 4, which again is the same as g of 4 times f of 4. So we're going to go ahead and look up those values. G of 4 would be 0. And then we have f of 4, which doesn't matter because we're multiplying by 0, but you just want to go through the process. It's going to be a 5. And if you multiply those together, then we get 0. All right, I want you guys to go ahead and attempt E and F. We are doing the same process, but we're using different domain values. So you're going to find f of 1 and then add to that g of 3. And then for f, you're going to find g of 4 and divide by f of 0. So go ahead and hit pause now, try those problems, and then check back in and see how you did. All right, you can see that for E, I got f of 1 was 2, g of 3 was negative 1, and when we add them, we get 1. And then for f, I have 0 over 5, which is just 0. All right, something that's a little more challenging now, a little more abstract. We're going to try and add two functions based solely off of their graphs. So when we're adding them, we're looking at points we can identify, and we're going to be adding the corresponding y values. So at 0, I notice that I have a value of 0 and a value of 6. So if I add 0 plus 6, then I get a point that's going to be at 6. If I look at my next set of values, I can see that at an x value of 2, I have, again, a 0, and we have a 4. So when x is 2, if I add 0 and 4 together, we get 4. And then the next concrete points that we have are over here at 7. And at 7, it's a little more challenging to see what our values are. But I have a value here that's a little bit below 3, and a value that's a little bit above 3. In fact, the same distance below and above. So it's like 2.9 and 3.1. And when I add them together, we're going to get 6. So again, for an x value of 7, if I add those two y values together, we get 6. I'm going to go ahead and put that point as well. And now I can connect my dots, and this is what our graph would look like. All right, we're going to try this one more time here. Again, we're going to be adding functions, so we're looking at a common x value, adding the corresponding y values, and seeing what we get. If we look at our first x value of -4, I can see I have a value of 1, and I have a value of 3. And if I add 1 and 3 together, I get 4. So at -4, I have a value of 4. For my next x value of -3, I see that I'm just at 2 for both functions. 2 plus 2, again, is going to be 4. When I have an x value of -2, one function has a value of 1. The other function has a value of 3. 1 plus 3, again, is going to be 4. And we're going to keep going. If I look at my x values of -1, we have the same things again. So when x is -1, I have one function f, which is going to be 1. G is going to be 3. 1 plus 3 is again going to be 4. Okay, we're going to have a little bit of a change here. We're not going to have all those 4s anymore. When I go to an x value of 0, I see that my f function is 0. My y function is 2. 0 plus 2 is going to be 2. Okay, I'm going to pause it now, and I'd like to see if you guys can add the rest of these and then check back in. So add the add the corresponding y values for x values for 1, 2, and 3, and then see how you did and check back in. All right, so let's see how we did. For an x value of 1, we see we have a y value of -1 and 2. When I add those together, I get 1. For an x value of 2, I have a y value of -3 and 2, and then -3 plus 2 is going to be that -1. And then finally, for an x value of 3, f of x is -5, g of x is +1, -5 plus 1 is -4. And now that I have all of my points, I can go ahead and connect my dots. And this would be the graphical representation of f plus g. All right, that does it for 1.5 part 1. Go ahead and get started on the homework, and good luck.